So to kick it off, we're going to go to this MD file right here on our GitHub, and I can have a QR code for this. For you to use. So if you go to here, you will have access to this. I can also just type in the URL in the chat.
Yeah, let me pop it in the chat real quick for us. So the chat interface on your bottom right-hand side, there's the URL that we're working on today.
It's right here. Everyone get here all right? If you also just Google search Austin LangChain on Google, Austin LangChain GitHub, and go there. That could work. Austin LangChain. GitHub. First one comes up. Yeah, exactly. And then you go to resources and Quickstart. It will lead you to that MD file. Okay, so we're going to briefly go over accounts that you will need to set up here. Then we'll dive into setting up environment variables. And that will pretty much be it. And then Docker briefly as well. So, okay, accounts. Has everyone heard of OpenAI? I assume you have until this point. But if you haven't, that's where that's mostly the models that we work with. If you go to this account right here, to this link right here, it will prompt you to create an account if you don't have one, and you need an account because you need to use their API key in order for you to use the models on the Colab notebooks and in your own machine. So you need an account for that. And we'll just lead you to this page. Does anyone not have an OpenAI account?
It's a free one. That work?
You will have to pay for your own tokens. I believe they give you a certain amount of tokens for free when you sign up.
But generally, it's recommended to pay for it. It's basically you load it up with a couple bucks. So if you don't have an OpenAI account that's paid for, you load it up with a couple bucks. You know, if you're just playing, you're probably going to use like $1 or $2 a month.
Cool. So once you're there, you're going to want to go to the API keys tab, click on that, and then you will want to create a new secret key. And that's what it's going to look like.
So you've got the dark mode set on OpenAI's website. Is that right?
Yeah, this is like a screenshot I took, but yeah, that's what it's going to look like. If you click on API keys and create a new key secret key. Yeah, so you just need to generate a key. Okay, so does everyone have an API key from OpenAI? Awesome.
Yeah, sometimes they'll do that to make sure you're not hacking it.
The next step is LangSmith. Who has not heard of LangSmith? Awesome, makes sense. So LangSmith is sort of a tool to developed by LangChain to give visibility into what's happening under the hood as you run your AI applications with LangChain. It kind of gives you a trace of everything that's going on from the call, from where the user started the query to the LLM to process it, and all the various components along the chain. So it's a very useful tool for that. Basically testing and debugging. You kind of think of it as that. So you'll want to go to this link right here. Right here, LangSmith account sign up. Click on that. It'll lead you here. It will look something like this once you have an account and you're logged in. But what you want to do is basically get an API key for this as well. So all these API keys, don't share them with anyone else. Keep them for yourself. If they do get compromised, just delete it, make a new one. So then you'll want to go to settings. Actually, I'll wait for anyone. Has everyone created an account? LangSmith.
I just finished looking at it, but I'm going to give up and I'll just watch. Just let me know the pace is too quick for me. Keep it
No problem.
Because no one else will complain.
Sure. It's the link is right here if you want to follow along.
Yeah, well, there's two things to do. So I have to shift back and forth. It's delay in seeking.
No problem.
Seriously, I'm just going to.
So you'll want to go to settings, and you will click on this button right here, create API key, and that will give you a key. Just copy it, put it somewhere safe for now. So at this point, you should have your OpenAI key and your LangSmith key. Has everyone generated an API key for LangSmith? Awesome. Anyone still? Okay, no problem.
I have a question. Once we are waiting,
Sure.
is there any option like open source option that does kind of the same?
Yeah, so we work with CPU models like all the time, but generally when we're trying to like prove out like a proof of concept, it's really easy just to use the OpenAI API.
Well, I'm talking about the LangSmith part. You know,
Uh-huh.
to observability monitoring like that.
Oh, okay. Yeah, actually, I think there's other frameworks around. Actually, a friend of mine I went to high school with developed a software company. Like he started his own software company just for this. Like basically doing what LangSmith does. It's called Vallum. I don't know if people have heard of it. But generally, if you're already using LangChain, you might as well just use LangSmith too. They're kind of they work very well together.
It's free right now. There's also
Awesome.
yes. There's also LangFlow, which you can run on your own computer out of Yahoo Combinator. There's a few more. There's a few options. You can also debug locally.
Yeah, so LangSmith's completely free
Right now.
right now at the moment.
This is the thing, right?
Yeah.
It's a good tool. I mean, it's good, but it's
So to echo, LangSmith right now is a paid platform. The other you can always output. You can debug it to a string. and see the debugs going through. There's also a project called LangFlow at a Yahoo Combinator right now that you can run it on like a Docker image, and you can get a very similar interface. LangFlow is offering like the first, I don't know, smaller amount of messages free. We expect the LangChain AI team to effectively have a parallel to them. But the LangSmith is kind of an integrated debugging interface for the project. It's good stuff. It works pretty well.
Cool. So next thing we're going to do is go to Google Colab. Who has not heard of Colab? Awesome. So have you guys heard of Jupyter Notebooks? Awesome. So yeah, that's basically Colab. It's Jupyter Notebooks hosted by Google. By default, when you have a Jupyter Notebook on a GitHub repo, you automatically get a link for a Colab notebook. That basically lets you just run a Jupyter Notebook, just being logged in the web. All you need is a Google account. Does everyone have a Google account? All right, cool. But if you don't have one, you can go click this link right here, and you can create a Google account. So then once you click on this link to go to Colab, and if you have a Google account, you should just see this right away. There shouldn't be any other tinkering with. Here. So if you click on this link right here, LangChain 101, that will lead you to a previous notebook that we have in our repo. And if you see that, you're in good shape. You have Colab that's working for you. Everyone able to get here so far? Awesome. So now in Colab, what you want to do is once you set up environment variables. So we work a lot with Colab because it's really easy to put your environment variables there and share code and run it in sections and blocks. So you can see exactly what's happening in every section of the code. So with environment variables, Colab does this very cool thing where you can store environment variables in basically your account, and then that persists throughout all the notebooks that you run. So super useful. It's very easy. All you got to do is just go to this key icon right here, click on that, and you'll want to store your keys right here. So you'll basically do add a new secret key. You just type in the key name right there, and then here you'll put in your actual key. So for the OpenAI API key is just this, OpenAI underscore API underscore key. And then the LangChain is going to be, that's for the LangSmith, LangChain underscore API underscore key. So those keys that you got earlier from OpenAI and LangSmith, I want you to put them here. So far, so good? Cool. Now, there's another way to, by the way, this is how you would use it in your code, if you're wondering. If you ever need to reference this, you can just go to this MD file, and you can see it here. Google also tells you how to use it here, right under where you declare your environment variables. Access your secrets keys in Python via this block right here. And you can also store environment variables in your own machine. OpenAI has some pretty good docs on how you do that. If you go here, you don't really need to do that for today. We're just going to be running collab notebooks. But if you ever need this, you can just go to our MD file and GitHub, and you can see yourself. You can also very easily Google how to do this for your own OS, like if you're on Windows or Mac OS. The final piece of this onboarding is setting up Docker. Who has not heard of Docker? Awesome. Okay. Everyone's heard of Docker. Super useful tool. Very good for us to run our models, especially the ones that code. It can do some harm to your system where you're running it. You can run your these our chains or models in these like sandbox environment. They're also Docker is also really cool for just sharing code with people. So the same code works on different environments. Super cool, super powerful. We use it a lot here. So if you go to this intro to Docker tutorial, so that there is a link here, intro to Docker. It would actually lead you to a previous tutorial that we made here on how to set up Docker. And all you really need right now is to install it on your desktop. It's really easy to do. So you just go to Docker desktop right here, this link. You can also just Google Docker desktop, download.
Do you need a Docker account?
Not necessarily. Yeah, you just need to download Docker. So you can download it here for your OS. Oops. Does everyone have Docker downloaded? Or anyone not download Docker? Okay, well, we're not going to be using Docker today. It's just going to be collab notebooks. So if you were able to get your environment variables and you put it in collab, you're in good shape. Cool. Let's see how we're doing in sessions. Is there anyone here? We got 16 participants. Oh wait, there's people over here. So the people on that line. Is everyone connected here, right?
Yeah. There's also people remote.
Awesome. I think that is it. If does anyone have any questions?
Do you want to go through the first notebook?
Yeah. Let's get the agenda here. We had news and updates first.
Oh, I thought we were going to go through just that first short update, or the first getting started notebook that you had merged.
Yeah, it was this one, right?
Okay.
Getting started.
Cool. Okay. Cool. Let me make sure that let me get everyone else in here for the meeting.
Will our accounts work later if we try to come?
Yeah.
It's not like kills or anything.
No.
I'm sorry, it's the calling cameras?
Call him McNamara. The GitHub?
Oh,
Is that what you're trying to look for? Yeah, this is a repo. Austin LangChain. If you just look for that on Google, you'll find it.
oh, that's easy.
Okay.
Is it up here?
Come over on this side, and Ricky's just going through. Are you going to go through that quick notebook, or
The Streamlit one?
I don't know, whichever one you wanted to?
I don't
Or
have
just
a notebook.
the one.
Yeah.
Want to do this and kill it.
Yeah, because we just show them how to do the environment variables, right?
Okay. Yeah. Should probably switch over, and I'll get started, and then sound good.
Cool.
Okay. Cool. So the Wi-Fi is on this little bad boy. Can you draw it over here?
Yeah, thanks.
So here.
Year ago, I ran into LangChain because we were working with manufacturers who are really our clients to take a beverage product to market. And I was using, and I ran into the data challenge from the LangChain project and used it to create pitch decks for investors and stuff like that. And what it actually uncovered was fraud in my supply chain. It saved me from an SEC violation. And I was like, holy smoke, this is a rad project. I need to share this with people around me. I need to connect the people who are using it. And over the past probably 6 months of this group, we've been seeing awesomeness happen as we're all just learning in the open. So yeah, I got nothing to sell you, man. But hey, when the gummy bears go to market or some of the juice boxes, I'm all happy. You want to drink some juice, get some gummies. I'll hook you up for free. Okay, so Ricky gave a little bit of a one-on-ones quick start coming on. That'll kind of get you prepped. And this is our AI imagery and gaming session that we're doing today on 4/3 in Austin, Texas. If you click the QR code here, this is our repo. We have basically a hacking repo where we put presentations, we put all sorts of fun things. So if you go to github.com/Colin McNamara /Austin_LangChain. You'll see some folders inside of here, right? So here you have labs. What's inside of labs? Well, we have our meetings, our in-person meetings just like this, our first one, our second one, our third one, our fourth one, our fifth one. And this is our prepping for the next one coming up is 106, but we're in 105 right now. But there's a whole bunch of labs that you can go through and notebooks. And for those of you that got set up with your keys and you're new to this project, maybe you go to 101 and you go to Streamlit Streaming and you click Open in Collab. Well, you can start following along and literally just press play and run anyway. And you can start coming through, you can start running through these and start playing with it on your own. And we'll go ahead and host like a full 3-hour 101 quick start, every once in a while. We got to figure out when the next one's scheduled. Cool. Again, this project and the people inside of it had terribly impressed me. The people that we connect with here in Austin continue to impress me. And people that are using this project are really staying on the cutting edge. And we're finding, for those of us in the core group who work together and contributing code, we're finding that even though I feel stupid all the time, that we tend to be on the cutting edge. Just by the fact there's a new release, there's a new thing, we're playing with it. And some of what we're talking about here today is on the cutting edge of AI technology here in Austin. How weird. Okay, so our agenda. We're going to go over one message, give some news and announcements, and then we're going to go and talk some labs. The first one will be integrating AI with web applications with Paperspace. James behind me? James, right?
Yes.
Yes, okay. Next, and why James is going first, one, it's cool. But two, it allows you to basically access hosted GPUs. If you don't have like a 4090 card at home or a GPU at home, like my only GPUs are on my Macs. You have to rent GPUs from somewhere else to run some notebooks, run some labs. So this will get you set up for the second talk we have today. And again, you might not be able to follow along quickly all the time, but it's recorded. All the resources are there. All the stuff's in the repo, so on and so forth. Next, we're going to follow up with a thing that was really cool. At our hacky hour 4 weeks ago, excuse me, the last hacky hour, I was hanging over Kareem's shoulder being like, dude, what is on your screen? Our hacky hours are where we come and we bring our laptops to a local bar, we hack on code, we hack on labs, we hang out, we drink beer, eat pizza, whatever. And Kareem was showing me some really cool stuff with Stable Diffusion, how he had this really cool image workflow. So what Kareem did was he integrated it with LangChain. And so now LangChain, this Python project we use, is actually like making images and stuff like that. So he's going to go over and do a showcase on that. And then last we have D Manning. Are you here? Sweet. Okay. Please, with your laptop, before it comes to you, get all set up on the sessions interface so we can make you presenter. Whatnot. Did you get the email with your login information? Okay, cool. It may have come like at last minute. We might have to fudge around. Is Don Manning, right? Dan? Dan Manning. Okay. Dan, local Austinite game developer, made a really cool application where NPCs in games are interacting with each other in a virtual world, all in LangChain, and you can interact with it. Kind of neat. Kind of blows my mind. So again, those are the talks and labs we have going over today. I'm really impressed by everyone and everything, from the one-on-one Quickstart and the docs and the work that Ricky put together to our future presenters. Okay, so a little bit of Austin LangChain, welcome. We have a Discord. Yes, Catherine. The password for the Wi-Fi is on the clear thing that's floating around. Thank you very much for asking for that, and my apologies for not.
1204 gets lowercase.
Thank you. And I appreciate everyone's help. It's it's hard when you're facilitating to keep everything straight all the time. So if I go off on a rail or forget something, hey. Okay, so we're local in Central Texas. We do have people that connect in from all over the world on our Discord. And via our virtual interface on meet.aimug.org. So our Discord the link is there. I encourage you to join it. We have some chatter that happens on there. It's where we do our community call. Excuse me. It's where we do our office hours. Also, like some new comes out inside there. For example, we have someone in Brazil right now that I think Ricky's helping out or Kareem's helping out. Excuse me. He's using Ricky's code for your Google Drive code. They went and pimped my G Drive, and Kareem's helping them out on there. So running through labs, you run into problems, pop in there. We're here to help, right? This is a community organization. It's for public good. It is a public good. We have, again, the GitHub on there. It's under my account right now. Eventually, I'll move it up to like an organization account or something like that. As this group is growing, I think we have 350 people or 360 people in the meetup. It's kind of getting scary big. Our meetup is right there. You can go to meetup.com. I do announce on Twitter at Austin LangChain, usually just like what we're doing, when we're doing type of thing. If Twitter's your thing, we have a YouTube channel where the videos from today will get produced on there and edited out. If there's anything we got to, if someone accidentally slipped a key or something like that, and we'll be there for your review. And again, if you're in the sessions interface, you have access to the transcripts, you have access to the recordings, you have access to all the notes and stuff like that you put. So hopefully you can make stress of it. We host Austin LangChain generally monthly in person like this. And then we do, in the middle of the month, we've been doing hacky hours where we get together at a local bar, explore the cool things that Austin has to offer, hang out with each other, and show off our code. We are consolidating the virtuals because honestly, it is a lot to do a virtual from home, do an in-person here, and do a hacky hour. Let me see, but our focus is low stress, right? So we want to learn and share. And again, it's low stress learning and sharing. We want to connect with other early adopters that are inside here. There's a lot of doers, a lot of makers, a lot of people there's business people that are effectively integrating. Rob's a great example of that, for your energy investing and stuff like that. Blows my mind what he's been able to do from sitting here I remember you're like, I'm not technical. You're like, oh yeah, I get LangChain gives me a report every morning of all this cool investment stuff that I'm doing. Maybe not so technical according to you, but you're using it for business use. You're doing stuff. I think it's rad. Again, our focus is learning, sharing, and growing. We have a very simple code of conduct. Be cool. Like, don't be uncool. Be cool to each other. Don't be gross. We know what that means. If anyone doesn't understand that or has a problem with someone being uncool or being gross, come to me. I'm a Marine. I'm a firefighter. It'll be dealt with. And the most important thing about being cool is we're all learning. I've done this 8 times in my career where I go from being like an expert in hyperscale or an expert in global voice or global storage, and I go down to something I'm really stupid at. And we become toddlers. We really become insecure, we become unsure, we become really vulnerable. So really embrace, be cool to each other. Just because, if any of us are super smart or in different areas, we're all learning, right? So give each other some grace. I want to make time to thank our supporters. Meaning Cannot allows us to use this amazing space for free. Amazing, thank you. If you're ever in trouble with the law, please use them. Or if you plan on getting in trouble with the law and you need an opinion, use them. I want to thank KeyChange, who focuses on like early venture business growth for our beer and our name tags, and Charles and for being a positive energy and helping facilitate a lot of really great stuff in the community here in Austin. I want to thank my partners at Always Cool Brands for allowing me to spend so much time fostering this community, but also for our sessions interface and other things like reserving tables at happy hours and stuff like that. Most importantly, I want to thank our contributors for our code, for our content, but also consuming it and contributing our community. So news and announcements. Let's see, does anyone have any questions about who we're doing, how we're organized? I'll reiterate, we are a public good. We are learning in the open. We have nothing to sell you. Occasionally, people who work from companies may present and talk about that, but it's mainly because we think they can add value to the community. We do not take compensation for what we're doing here. Okay, news announcements. We have a scheduled in 2 weeks at Central Machine Works. That is on the east side, on like 5th, kind of near. Am I turned around? That way. Okay, cool. I live on the east side. I should know this. You do too. That's my favorite bar, and happens to be where when I posted a thing on Meetup, and Charles was like, "Yo, like, what's up?" And I'm like, I got an idea. I can get you through some. I want to share what I've been able to do for myself. And I thought it'd take like an hour, and we're there all night. But as you know, sometimes these things go long. Just letting you know. So, anyways, we have a hacky hour on the 17th at Central Machine Works. It is no stress. Bring your laptop, hack on labs, hang out. I got 3 tables reserved. We have plenty of space. Be cool to your servers. Grab a beer. If you're not into beer, grab something non-alcoholic. The pizza's great. So are their nachos. Let me see. What's up? So to echo back for people that couldn't hear online or who weren't clear, we're throwing beers for people to do cool stuff, right? And if you don't drink non-alcoholic beverages or whatever, I don't care. I think it's cool to just give someone a high five for stuff they respect. There's things that are really interesting to us. I merged somewhere in there. I think on the Discord, put some interesting code examples for code to control PII escape. It's be really cool, and I'm personally working on some stuff. But the whole idea is that we can start throwing some positive reinforcement around. for people that are creating patterns and then distributing them out in the community. I think it's really, really neat. Beer, pizza, I don't know. We'll see where it goes. If anyone else wants to join us in throwing some beers in the kitty for people showing off cool stuff, you know, talk to me, talk to Charles, hop on the Discord. Okay, let me see. Anything else we can cover about hacky hours? There seems to be a structure that's happening. One time in here, doing formal stuff, presentations, recording, whatnot, and another time out on town enjoying this wonderful town that we live in. And let me see. So office hours, we've been experimenting the last 2 weeks. We're going to continue, I think, yeah. With at 2 o'clock on Tuesdays, hopping on the Discord voice and video channel and doing office hours. It's been really great. We've had people pop in asking for help, for having discussions. We've been hanging out. I know that I've gotten stuff figured out inside of there. It's really great. Usually having a break midday on Tuesdays and chatting with people. And luckily, Kareem, not only is he really, really smart, so is Ricky, but both of them are really, really cool. And there's some really cool discussions that are happening inside of there. Our community calls are at 2:30 on Thursdays. Generally, those are more structured meetings where we're planning our events and stuff like that. So if you are a person who adds value to a community by helping make things happen, you don't always have to be like a super cool hacker person, right? Hop on. You know, the more the merrier. Other announcements, we posted a video exploring LangGraph from our last virtual session. As we got a good recording, I think our in-person we weren't able to capture recording. So if you want to review any of the LangGraph stuff, it's up there on our YouTube channel. And then last announcement, Catherine over there in the corner, do you want to talk about what you're doing on the sub? What do you want me to? Yeah. It's Echo for those that are, sorry, what? So 12, it's Echo, Catherine, so I'll be there. Been bringing a +1. I'm gonna go shoot some nerds. I say this lovingly, I am a nerd, right? We recognize ourselves, but y'all gonna get shot with some laser. I'm gonna do like a combat roll. You probably shoot me in the back, it'd be cool. So again, that's at 12 noon on Sunday. Okay, next, call for papers. So there's people in the core group who do the work, that write notebooks, that create code. Really happy today that we have people coming in from the outside to talk about new people to the group, bringing from Paperspace, giving talks, from local community, and I'm forgetting the name of your video game company. But please, if you want to talk about something, if you've done something cool, if you want to showcase something that's you think might be a little too simple, we want to give you the visibility, we want to give you the stage, we want to give you the support. So please hop on the Discord, hop on the community call. We'll coach you through it. It is a safe place to be a nerd and show off what you're doing. This is not the call-in show. This is the show for our group. Okay, we talked about our last meeting. If you want to review it, it's right there. So again, everyone log into sessions. And then I'm going to hand it over to James. So James, are you on the sessions interface?
Yeah.
Okay. I'm going to put my glasses on so I can see you. And we're going to flip things on over. I'm going to sit back and learn some stuff. James, let me give you a moment here. I'll figure some stuff out. Make assistant. James Skelton. Okay. I'm going to stop sharing. So in your interface, can you share? Here, let me give you the video. One moment. Here's the projector right here. Don't have any hold music, but you know, we can imagine some like Girl from Ipanema going. Okay. Let me make you. There's that. Cool.
I'm gonna put myself on mute real quick.
Session. Okay. So we can all see this now?
Yeah.
That didn't break it? Good. I was worried. All right. Hi, everybody. Thank you so much, Colin, Kareem, all of you for having me. I really appreciate it. And thanks so much for your time today listening. I'm James Skelton. I'm a technical evangelist for Paperspace, now by DigitalOcean. That's a recent thing. I'm still not used to it. And today I'm going to talk about integrating AI into your web applications with Paperspace. Got a nice little session prepared for y'all here. I'm going to start by introducing Paperspace, just kind of, give everybody a quick taste of what it is before we dive into it. Then talk about developing with language models on Paperspace. Talk about our GPU offerings. Then I'm going to talk about the Surge application, which is what I'm going to be showing today. It's a fast API and LangChain enabled, I guess you could say, serving application for different GPT models. Talk about how it uses LangChain, and then we're going to talk about how to actually use Surge with Paperspace. So creating a deployment through the UI and interacting with your deployment through the API endpoint. Then we're going to actually look at the demo itself. I've got one running, and you can go along with me if you so choose. Don't totally recommend it right now, because I'm going to be running on an A100, and that stacks up if you're not paying attention. And at the very end, I'm just going to talk about what I would like to talk about next time I see y'all, which is deploying with LangServe and Paperspace. But I didn't have time to develop a whole proprietary application this time around. I just realized they can't see me. Does that matter? Oh, you can. Okay, cool.
Yeah.
Cool. All right, so let me give you all my my Paperspace pitch. So what do we do? Who are we? In short, Paperspace is an MLOps and cloud VM platform specifically focusing on giving GPU power for AI model training and deployment at scale. Specifically, we have two main products to know about. They are our virtual machines on Core and our MLOps platform on Gradient. This is mostly talking about Gradient here, but with us, it's pretty easy to launch a IPython notebook with our notebooks, do your training with a core machine, and then deploy using the deployments. It's definitely built for AI developers specifically. I should know, I torture myself trying other tools all the time. It's got really nice wide variety of GPUs, which is really my favorite thing about it. So if you need to use an H100 for your task, which is coming out more and more these days as these language models get bigger and bigger, we have them, but we've also got as small and cheap as Maxwell M4000s, which can be really nice if you're running something lightweight. We've also got pre-configured deep learning containers to make it easy for doing your coding. So if you're ever starting an IPython notebook with our notebooks product, the Docker container has everything pre-installed. So you don't need to go through a lot of the setup you see in stuff like Colab. Gradient is the name of the ML platform itself. It's got all the tools in there, and it comes with a lot of really nice kind of inbuilt features for collaboration and sharing. In fact, I had every intention of offering credits for y'all today. To make a long story short, we're recently acquired. Integration is going interestingly, and I have to manually enter it. So we're going to talk about it later. But the other option is I can make a team and just give everybody free GPUs for a week. So we'll get there when we get there. It's an option for collaboration and sharing to the extreme, is what I'm saying. Yeah, this is just a little bit more about those. So the notebooks, those are going to be really familiar to all of you that have used stuff like Colab or Kaggle, AWS SageMaker, IPython notebooks through Jupyter. Machines, those are just virtual machines that are connected to our GPUs. They can be run on Linux or Windows. And you can get either just direct SSH access, or you can get like the entire thing in your web browser, which I quite like to use from time to time. I play PS3 games on my core machine. And finally, deployments, which is what we're going to talk about today, which is converting the models into scalable API endpoints. And it's got nice inbuilt features like security, health checks, everything you need to really take your application to scale. I'm not going to harp on this too much, but we're a lot cheaper than Azure and AWS. Let's not go there though. If you would like some more information, I will be sharing these slides with everyone. All right, let's get a little more into some fun stuff. So developing with language models on Paperspace. As I was talking about a minute ago, it's pretty easy to collaborate within a team space across various projects using notebooks. After that, you can then take that work, put it in a Docker container. I prefer to do that on Core, but you can do that wherever. And then deploy the application with Paperspace deployments. You can access the 8X, H100, or A100 GPU, multi-GPU machines on our VM platform. So if you're ever doing training or fine-tuning, that is 100% what I would recommend. And integrations with Hugging Face, AWS S3, and DigitalOcean spaces make it straightforward to plug and play with your different models if you build like a templatized application. Shoot.
Okay, question. So is the idea with Paperspace that you can deploy like a large open source model, but it's your own private deployments?
Precisely.
And how do you figure out how many nodes you need, how many GPUs? Like you did Llama, 7 billion, something like that.
Yeah. Well, you'd have to. I mean, have to be some intuition there for sure. Llama 70B. Just kind of think about how many. Well, I would just Google how much RAM.
I guess that's
Yeah. Let's do like Falcon 180B or something that won't fit on a single GPU. What we would do, there's auto scaling. So it would automatically scale up the size of your deployment to match the compute needs, and then match the machines with NVLink. So it keeps things smooth as you need to scale up, which is a really nice feature. But yeah, I'm gonna show the deployments tool itself in a lot of detail.
Yeah, so I never heard of it. So like ChatGPT or what's the one with the Claude?
Anthropic?
Yeah, those are those you access a large language model via API.
Yeah, so they're doing all their compute.
You own the deployment.
Yeah, exactly. So whenever you're using an OpenAI API call, it's doing all the compute on their end. If you wanted to set something up with a open source model where you are controlling the entire environment, this would be a good solution. Honestly, you could run this on a CPU and do API calls too if you need to, and then just abstract away the GPU problem. But there's plenty of services that do that. I would like to talk about what makes this special today, right? This is just a full list of our GPU offerings. I recommend perusing it from time to time, just to see as we grow what else is there. Hopefully H200 is coming soon. Can't promise that. But we've got everything from Pascals to Hoppers, which is really nice when you're not trying to break the bank, just testing out a new model.
Interrupt you again.
Fire away.
I don't know anything about GPUs. Like that whole list of A100X, I don't know anything about it, and I want to learn though because I think it's important. So if anyone has a good resource, maybe put it in the chat.
I will. I can definitely do that.
Cool.
That's our whole Paperspace blog got you.
Like I wouldn't even know which one to choose, and I want to figure out like.
Well,
how to do it, you know what I mean?
I mean, quick nutshell: M4000s are about 12 years old. Pascal 4000s are, I don't know, 6 or something, I think. Then RTX 5 or 4, A3. Voltas are actually older, but yeah, the terms stand for microarchitectures. They're all named after different mathematicians and scientists. That's what NVIDIA likes to do, I guess. The new ones are Blackwell, for what it's worth. But yeah, I will share a resource on what this all means. Absolutely. Okay, so what is the search application? What is the thing I am presenting on today? Appreciate y'all listening about Paperspace. Let's talk about something a little more fun. This is just a quote directly from their GitHub repo, but Surge is a chat interface crafted with llama.cpp for running GGUF models. It requires no API keys and is entirely self-hosted, kind of hitting on what you just asked coincidentally. In practice, it's an application for serving large language models with a SvelteKit frontend, Redis chat history and storage management. That's actually done by LangChain. And a fast API plus LangChain API to wrap calls to llama.cpp using Python bindings. In practice, this just lets you speed everything up while you're running on your GPU, and it's packaged all in one tight little application that lets you kind of get everything together in one spot. I'll share links to this later, but they're also in the slides. But this is the GitHub repo for Surge. It's a really cool project. Please start it if y'all like this presentation. I would love to support them some more. Okay. Just making sure. Oh, I screwed that up. That's good enough. Okay. So how does Surge actually use LangChain? So I went into the application files, digging in, trying to find where they were actually implementing some LangChain features. These were namely in the chat.py and stream.py, which makes sense if you think about it. And we can click in there using those links to see them. It's using, and I realize this is far too small to see from there, but LangChain.memory, import Redis chats, message history, and then it's using LangChain.schema to do the system message, messages to dict, AI message, and human message. So what do these do? Well, the Redis chats history is for memory management of the chat. It organizes and stores all of your different chats using Redis across the application, which is really nice and useful for managing a bunch of different chats. Here's the actual application itself. Sorry, you can see right here, I've got 2 chat windows open, but I think it can support as many, as your storage can handle, which is really, really useful. And the schema-related functions like AI message, human message, and system message, they do the organization for your chat history. So if the LLM is sending a response, it'll be AI message, human message is your inputs, and system message is logs, basically. These really help to organize the entire conversation and make the application run more smoothly and more efficiently. They also functionally log the interactions between the user, system, and model, enable quick access to previous chats logged by the Redis database, and enable a ton of different quality of life features like history purging in an application. So it really simplifies a lot of the things that go into managing a chatbot, which I really like about the application, and we owe it to LangChain here. So I wanted to make sure we gave that credit there. Next, I'm going to dig into how to actually deploy Surge with Paperspace. So in the GitHub repo for the Lab 5, there's a README in the Paperspace subdirectory.
Which specific repo is in the Surge repo?
So Austin LangChain Labs, LangChain 105, there is a subdir called Paperspace.
Okay.
And I put in a README with the instructions. This is a bit of an experiment. I have not put this into text format before. I've just talked it out with people or shown schema. So if this isn't particularly clear, give me feedback and I'll update it for sure. But I'm going to walk through the entire process here. So how to actually launch the deployment. I'm going to sit for this part. All right. So the first thing we will do is go to console.paperspace.com. If you don't already have a Paperspace account, this is where you can sign up. We do have free accounts, just so y'all know, but if you're ever using a GPU, it will cost money, but there's never any hidden fees in my experience. And I've been using it for 3 years and before they hired me, so good experience. Yeah, once you're in there, this is just one of those teams I was talking about where you can do different collaboration. I'm just going to jump into this project. This is just where I share a lot of the work. I have my GTC demos here, for example. And then go over to the deployments tab. I think this is, oops, sorry. I've got so many tabs here, I lost my spot. Put that there. All right. So now that we're in the deployments tab, we can go right here in the middle and hit create to actually create the deployment. And then actually I've put all the things you need for this setup right here in the demo slide. So just a heads up, that can make it a little bit easier. So we can just go through here, quickly select our machines, and set. I'm going to use an A100 80 gig GPU for this. This is the most powerful available on Gradient right now, although the H100s are coming online pretty soon for Gradient. Again, I don't recommend it right now because it's $318 an hour. P4000s are 50 cents, and they will run this just as well. Just probably not as fast.
Do you have any guidelines on GPU sizing for workloads? Like how do you figure out whether you want to go for a 4 or 5 year old GPU versus for 50 cents an hour versus an A100 or a new Blackwell?
Yeah. General answer is look at the VRAM and look at the bandwidth and look at the CUDA cores. Those are 3 values for GPUs that kind of correspond to strength. CUDA cores. Yeah, CUDA's the yeah. So CUDA, the software layer for NVIDIA GPUs, but they have specialized cores that are like they're the mini computational modal in the GPU itself. I know that's not the right word, and I apologize. Hardware is not my thing, but core. They're the CUDA cores themselves are the tiny individual units that are doing the computations. So with each successive generation, the CUDA cores advance, and they were able to use that and a few other less intuitive things to increase the bandwidth as well. But generally, so like Hopper has the same VRAM, like an H100 and an A100 both have 80 gigabytes of VRAM. But Hopper has significantly higher bandwidth and significantly higher CUDA cores. So if you are trying to do something more quickly, it'll be more efficient. But I think Hopper for us is 594, and A100s are 318. So you have to kind of do the calculus there about time, how much time you're going to need to actually use your thing. Really the question, honestly, is are you training or are you doing inference? If you're training, the answers almost always go as big as possible. If you're doing inference, serving a model, then things get a little trickier. Yeah, that's a good question. It's not a solved problem. That's for sure.
Good to know.
James, you said earlier that you say you got an auto scaling feature. How does that work? Does it scale like vertically to a bigger instance size in terms of RAM? You can use a sort of threshold, so you can start small and let the thing do what it's going to do?
Yeah, basically if you overwhelm the number of requests it's able to handle, it'll attach another machine. So all of our
machines then,
exact everything on Gradient specifically is well, no, actually, I take that back. That's what we're doing with the H100s. I apologize. I'm thinking about something different, but they're containerized, so they're sharing GPUs essentially, and it can easily allocate more resources to it that way. And then I'm worried I'm going to say something wrong here.
It's okay. Remember, we're cool. Everyone has to be cool, so it's okay. Like I've said some stupid shit, right? And like it was cool is everyone's like, hey, maybe.
I see you back there, by the way.
Yeah.
Sorry, no, go on, please.
Yeah, so you asked about vertical scaling on GPUs.
He was asking how auto scaling works. So we're probably working on it.
They probably just apply the same secret techniques to operation, right?
Let's see. Let's just go to the docs. Uses Kubernetes horizontal pod autoscaler. So it looks like it's horizontal, not vertical. Well, okay, language is getting confusing there. This is not my, I make cool demos.
And so you can hire for Kubernetes and then see how they're using secrets to like allocate resources for your GPU.
It's out of my wheelhouse, I'm sorry.
If you did vertical scaling, it would be maybe changing instance type on the price. So I'd be surprised if they gave you a bigger instance. I think it's probably.
Oh no! Oh yeah! It will. Right now, it's always going to be the same machine, same type of machine. So like if I select an A100, it will add more A100s. Things get complicated when you add different kinds of GPUs. Not enormously so, but enough that we don't bother right now. Okay, where was I? I was in here, creating the GPU. Yeah. Oh, I already filled in this one. Okay, cool. I don't have to go back and forth now. For the image, I'm sorry. The name, you can name it whatever you want. I'm just going to call this Surge. For the image, we're just going to use something that's on a public container registry. This is on in the, get this wrong every time, NVCR, NVIDIA Container Registry. And we don't need to add a default command. It's automated already in the Docker container. Next is the resources section. Here, if we wanted to change our port or add another available port, we can do that. For this example, we're going to use 8008. I believe it defaults same as Jupyter to 7860. So if you don't fill that, just heads up. Next is the replicas and auto scaling. Here we can initially set the number of replicas we want for our machine at the start, and then we can set parameters for how auto scaling will work. So a maximum number of replicas, the request duration, CPU utilization, and memory utilization thresholds we want to cross before it triggers the auto scaling to start. It's a little more descriptive than what I had before. Here are just some of the quick integrations. So if you wanted to do something like mount a, in this case, GPT-2 medium they have as their example model, it'll put this in the mount path that you set here. This can be really useful for, like I said, plugging and playing different models with your application. DigitalOcean Spaces and S3 buckets are two different storage solutions you can use. I'm very new to DigitalOcean, but I quite like their spaces. They're about as convenient as S3. If you haven't tried it, I recommend it. Environmental variables, let's say you're running a Gradio application and you need to set the Gradio server port, Gradio server name. That's a very common problem when dealing with the cloud and Gradio applications. You would do that here manually. And finally, we can do things like set health checks for our startup time, liveness and readiness to tell us when we are, verify whether our application has started, whether it's in a healthy state, and whether it's ready to serve requests. Finally, endpoint security, we can add a deployment key secret if we would like to add some degree of security to our deployment endpoint.
Seems very familiar. It looks like it's a front-end, graphical front-end for Kubernetes deployment.
Pretty much. No, pretty much. This whole thing is also, we have a CLI that does the entire same thing, and I'm pretty sure it just wraps around that. Finally, price summary. It's because I chose 14 A100s, 44.52 per hour. Depending on the scale, that can go up to 47.7, so it gives you the range. And like I said, I've had bad experiences with billing, and this one is pretty intuitive. I've been very happy with it. Once that's all done, you can just hit deploy, and it will take you to the deployment homepage. Whoops, going back here. I've already got one running for the sake of time. And here on the deployment homepage, we can see insights like how many replicas we're running, how much traffic we're getting, CPU percentage, RAM use, etc. We got our endpoint URL here, and some information about the replicas we've got running. In this case, it's just one. It's healthy. I can jump over to the logs and see what's going on underneath the hood here. And if we are iterating on the model or the application for whatever reason, we've also got a history feature. So you can download previous configurations, which are all stored in JSON or YAML format, and then relaunch it. All right. Now that that's all finally gone through, let me just make sure I don't have one more thing to cover. Cool. We want to interact with our deployment through the API endpoint. All we need to do is click the URL in the top right corner of the deployment details page. From there, you're going to need to download some models. There's a pretty wide variety there. I was kind of dismayed to see, unlike my other favorite tool, Llama Board, I want to shout them out, and I will again later, that you can't just plug in a URL from Hugging Face and download it, but it's got a pretty robust list. And then from there, you set your parameters and begin chatting. And I've got some more detailed instructions on how to do that setup in here. But it'll be very straightforward to all of you, I think. It's pretty traditional LLM interface. Yeah, say hi to Surge. It was originally designed as an easy way to chat with llama-based models, but since then, it's grown a fair bit. Alfred, Code Llama, Falcon, Open Llama right here, favorite. Yeah, pretty good list. Today, for this session, I downloaded Mixtral 8x7B Dolphin and Phi2, just kind of give examples of 2 different size models running on here and just showing what we can do with them. To start a new chat, you can use this little sidebar here on the left and put in your settings. So we got temperature, which controls how random the generated text is, maximum number of generated tokens goes up to 37,768. That's pretty good. Context length is at a maximum of 2048, which makes sense. Number of layers to put on the GPU. So if you are running a CPU optimized, I'm worried I'm going to get my acronyms wrong here. Is that GGML or the GGUF? Okay, thank you. So if you're running something GGUF and you've got we actually do offer crazy CPU machines. So if you wanted to do that on a CPU machine, that is very much an option. And then, other things like repeat last n, repeat penalties, number of threads to run llama on, etc. Here's the model choice. I'm going to let's just do Phi2. And finally, the prompt template. So this is the template it uses to handle your requests. It's kind of defaulted to an instruct response setting, but you can put whatever you want in here as a way to sort of prime the model. Because it's generating each token as it goes, that initial context will really affect the output. Once you got that all set up, we can start a new chat. So my new favorite test is to ask it, tell me about the mathematician Blackwell. I feel like caps matters. I already asked Mixtral this a while ago, and it didn't get it right. This looks right. Oh my goodness. Why? Oh, but it did just dump a bunch of empty characters at the end. Yeah, so Phi2 is a 1.6 gigabyte model, I think. 8. So it's remarkably small, and we're running on an 8100 right now. Phi is a really cool project, by the way. I mean, I don't love to shout out Microsoft, but shout out Microsoft.
Are all 4 of those in memory on your A100 right now?
So they're not in memory. They have to be loaded into the pipeline, and that's part of what's going on under the hood when you start a new chat.
Oh, okay. So when you do that drop down and you switch, it'll take a second to load 26 gigs.
Yeah. So we can I'll do a quick example right now. Do that Mixtral one, start a new chat. So the window comes up instantly, but did I spell that right? Yeah. It's going to take a little bit longer to get it all together, and it's going to take a little longer to do the actual setting. And we can see that in the logs if it will refresh. Is that? No, it is active. Okay, so it looks like this is what it says while it's loading the model up. So it doesn't look like this is good. Yeah. Oh, no. 56. It may have just loaded incredibly quickly. I may have to eat my words here. Yeah. Also, is it David Harold Blackwell? Any mathematicians know the answer here by any chance? Anyone? I don't actually know. It's very confidently incorrect.
It's not fake, but it's the same.
Is it correct?
Yeah. Yeah. Okay, no. Oh, no, never mind. He was African American. I thought it said African American Studies, and I was like, that's very not right. But yeah, while that's going, last thing I wanted to show is you can, the LangChain built-in features allow you to do all the database management for the chat. So we can go back and look at old ones, like this V one. I asked hi earlier. Oh, look, a bug. It's still printing from the previous one. Well, I didn't make this application. But yeah, that's the fun of it. It's I loaded a 2048 context length, so this is going to be a second. Oh, look, it's repeating. Well, not everything's perfect, is it? But especially live demos, right? Let's clear the chats. That'll wipe everything. Like I said, Redis makes that really, really easy. So thank you for LangChain for that, helping me deal with my buggy situation. Are you fixed? I think with that, I am pretty much finishing up here now. I've been answering, oh, I loaded in the Llama 13B model, so it's going to take a little bit longer to actually respond. With that, I'm pretty much done here. The demo instructions, everything that I did to actually launch it, that Kubernetes setup, as Kareem pointed out, is all right here. Those are the only values you have to paste in and change. So it should be very straightforward if you wanted to copy this. The only thing I recommend is changing that A100, and the machine codes are linked right there. So it'll be easy to change it. Next time I'm here, and I would really like there to be a next time. I hope you all enjoyed this. I'm going to try and develop a LangServe application. I was digging into it a little bit. It looks really like, I like Fast API. So something that works with Fast API, I'm a fan. And the invoke batch and stream endpoints particularly caught my eye. And I'm very curious if I can build something with JavaScript too to play around with it again. So JavaScript developers, you may hear from me too, if anybody wants to collab. Yeah, thank you guys so very much. All the links are in here in the README, so like the slides and the JSON. So we should all be good to go. Thank you all so much for listening.
Awesome. Thank you so much.
Whoops.
Love that.
Okay.
While Kareem's getting his stuff figured out, Kareem, one of our core members, has contributed a lot of cool code. Definitely, I learn from Kareem every day. And you're on mute. Okay, and Kareem is ready to go. So again, this is, shall I let Kareem talk?
All right. Hello, everyone. Thanks, Colin, for offering this platform. Bring everybody together, for learning in the open. Thanks, James, for the introduction to Paperspace, because that's what we'll be using for this demo. Because for this one, I had to load 3 models and do some things that Colab doesn't. Yeah, Colab doesn't support out of the box. So yeah, so for this so this is going to be a LangGraph agent. There's going to be function calling. We're going to be loading multiple LLMs. We are going to get read context from images. This is what we did in the previous one, but we're going to take it a step further, and we're also going to do image generation using automatic 1111. So let's get started. Like I said, so we'll be using loading local LLMs on this one. No OpenAI, no Anthropic. It's all going to be local. Like I said, multiple language models. We'll use Baklava model to read the image, context out of image, essentially image to text. Automatic 1111 for image generation from text. And for simple question answering, we'll use the Llama 2 model. Because this exercise needed a bit of function calling, and because I was working with local models, I had to employ a fine-tune LLM, and I'll talk about that a little bit as well. And we'll have 2 custom tools. And code is all of the code is in the repo.
I just put the link to your code in the chat, as well as if you click agenda, it's in the agenda on the left-hand side.
Okay. Okay. So automatic 1111. Most of you might have heard it before. Stable diffusion. It's basically a front end that allows you to load stable diffusion models and do image generation, against those models. Here's the screenshot. It looks, what it looks like. I gave it a, this one I had loaded the Dreamshaper XL model, gave it a prompt, an astronaut drifting away in space, and I don't know if you can see it, but this is what it generated for me. Now, to generate a model, yes, I only gave it the text, a small line of text, but there's a whole lot of other data that needs to be provided to the model. And some of that you can piece together by looking at this nice little UI here. There's the sampling method, sampling steps, whether I need high res on this one, whether I'm using a refiner, what is the resolution, what's the batch count in each batch, how many images I want generated, what is the CFG scale, and there's a few more other things that go in here. Now, in order to use that, automatic 1111 does allow you to launch with in API mode, which means that you can not only interact with it using the web interface, but you can also make web calls to it. If you know the schema, you can provide all of that information to it, and it'll return back the images that it generates out of those. Now, because we are making calls to an external system, we need something that you might have heard before called function calling. OpenAI popularized it with their models. LangChain, some of the most interesting demos that I've seen with LangChain involve function calling. Because without functions, you're just chatting with a language model, and you can only do so much. In order to go beyond that, you would have to essentially give access to external tools. And in this case, the tool happens to be automatic 1111 through the API. Now, I use Mistral for my stuff when I'm running locally. 7 billion models because I don't have a very powerful GPU. And out of the box, the pre-trained model or the instruct model from Mistral turns out did not have any function calling in its training data set. So what I mean by that, so if I give it a function definition in the form of, okay, you're a helpful assistant, use this functions if required, and it's a calculate tip function. It takes in the parameters of bill amount, which is a number, tip percentage, and both of those values are required. And if I say I need help calculating the tip. My bill amount is $50. I want to give a tip of 15%. I expect in return something that will take those two values and structure it in such a way that is consistent so that I can pass it to an external tool to work with. What I mean by that is I need something to come back, say, oh, you need a function called calculate tip, and these are the arguments. This is what my expectation is. But really what I get back when I give it all of that is, oh, here's some JavaScript code. I mean, it does a good job of piecing together, okay, you might want to call calculate tip function, pass it to this, but this is not what I'm asking. I need it to give me a JSON construct with that defines the function I want to call, not to give me instructions on how I could do it in JavaScript or Python. For that, because so there's fine tunes available that you could use. Dolphin or OpenHermes, I don't remember which one of those does a good job of function calling, but in this case, I just went ahead and I created a fine tune on with the data set that I found online on Hugging Face, and there might be a lab in the future where I can
I
go over.
hope there's a lab in the future where you show us to fine tune. It's super duper exciting.
Yeah. So now going on to tools, like I mentioned, there's two tools that we're going to use: text to image and image to text. How do you create a tool in to use in LangChain? Well, you define a function and you decorate it with the tool decorator. As simple as that. Now there's stuff that you're not seeing here. Text to image input is a pedantic schema that is elsewhere. But in here, I'm defining, in the doc string, I'm giving it a prompt essentially of, what I'm expecting when I'm giving it an input. And there's some custom Python code that I created for this one, and I'll go over that in a little bit. But basically, I'm creating a config, passing the prompt to it, passing any additional keyword arguments that I might pass. In this case, I'm passing it along. And if a seed is not specified, in this case it won't be, I'm going and initializing a random string, a random seed. And once I have that config, I'm making a request to the API that I am running for Automatic 1111 to this endpoint, which is what it exposes. And I'm passing the config basically as a dictionary, as a JSON string. So basically, what config is, it's really the request structure that is that Automatic 1111 is expecting for this text to image endpoint. I've just created a parentic object to make it easy to work with. Whatever response I get back, I take the JSON body of that and I return it. That's the first tool. The second tool is image to text. This is something that we saw in the previous demo, but basically again, function that takes in two parameters. First is the string, the prompt. Second one is the base64 encoded image that I want to use as a context. If there is, and then if there is no image provided, and we end up here, well, I want to return the error message, the canned error message, and otherwise, I will basically take the LLM, bind the images that I have, and then I'll pass the prompt to it. And whatever response I get back, I have this little bit of I call the function strip on it because for whatever reason the response I get back includes either a new line before it or after it or some extra spaces. So just to keep it a little bit cleaner, I strip those away. Here is our how the agent LangGraph agent looks like. We start from the left and we just follow the arrows. We give it the prompt, either ask it a question or ask it to generate an image or describe an image. It'll create the initial, it'll take that prompt, put it into the state, send it to the function identification tool. It'll do the first LLM call over there. So where you're seeing the circle, these are LLM calls that are happening inside the agent. First call is essentially look at the question and figure out what I'm asking. Whether I want you to answer this question immediately or whether I want you to use a tool to answer this. Based on that, it'll come up with one of two values, outputs. Either it's the question is something, it's a human question, or it's a function call. If it's a human question, then it just makes passes it to another LLM, the prompt itself, and then the LLM will give me an answer. We'll send it back. That's the end of that loop. If it's a function, then it'll invoke that function with the parameters, and it'll give you the response. This is how the app looks like. It's a screenshot. First thing I did was ask it its name. Again, not asking it to generate anything, just asking it a simple question, and it correctly identifies that, oh, this is a human interaction. So let me just respond with it. And because I'm using Llama 2 as the model to answer that, it's responding it as such. Now, my function calling model is a fine-tune of Mistral. The human interaction model is Llama 2. The image to text model is Bucklow. So again, 3 different models, 2 of them built on the Mistral architectures, but again, loaded as 2 separate models here. Then I gave it another prompt, said, generate a cartoon of an astronaut planting a US flag on Mars. This is what it came up with. Because now the thing with stable diffusion and image generation is you can give it the same prompts, pass it multiple times, and you'll get different responses. How do you get consistent response? Well, how do you get the same response out of it? That's where the seed comes in, because seed goes in as a parameter. And if you pass in the same arguments and you supply the same seed, you will get the same image consistently. So I didn't want the demo to just end here. It's like, what if you want to generate this image on your web UI using automatic 1111? So you could look at the the configuration, and you could say, okay, pass this prompt, here's a seed for that, and all of the other parameters that are going in to create this. So if you take this and you fill in the right text boxes and sliders in automatic 1111, load the right model, you will get the same image that was generated here. The other thing that will happen is I gave it the message of generate a cartoon of an astronaut planting a US flag. But if you recall, the tool description said, had a little bit of a doc string. Basically, what it said was look at the image, look at the prompt, and convert it into something that I would pass to Midjourney or something similar. If you look at the prompt here, it just says an astronaut in spacesuit holding a US flag, standing, and it's got something else. It constructed that from this prompt that I gave it. So, so that, even that's happening as part of your tool definition. Your tool definition has the ability to transform your prompt. All the resources that we use here, again, I'm using Ollama for, James used Llama CPP in his demo. I'm using Ollama. Ollama uses Llama CPP under the hood, but it gives you an API interface. Llama CPP, on the other hand, is a library. So you have to construct that on top of that, which is what Surge essentially is. It's using Llama CPP under the covers, and it's giving you a nice user interface. Ollama is using Llama CPP under the covers, but it's giving you an API front end for that. Automatic 1111, of course, is the link for that. For the Ollama model, I mentioned that I'm using fine tunes for function calling. The function calling model is hosted on Ollama. You can use it for your own. If you want to use the same format, you'll be able to use that. For your own projects and stuff. The template is hosted on LangChain Hub. So LangChain Hub is one of those things that we don't talk about as much. It is also something that LangChain offers. A lot of what we do with AI boils down to repeatability. We want to be able to use the same thing over and over and over and over again. And LangChain Hub is basically where you could publish your prompt templates for others to be able to use. So It makes my code a little bit cleaner because I don't have a lot of this, text prompt in there. I'm just making a call to LangChain Hub with my identifier, and anybody else who would like to who just needs a template, doesn't care about the code, what I'm doing, but they're interested in just the function calling bit, well, they can just go there and they can just use that bit. With that, let me just give you a quick run through of how you would run this. Okay, so on the GitHub repo, LangChain 105.
You're sharing another window.
I am I not? Okay. Select the window. Let's do sessions, I believe. Okay. So there is a notebook that outlines all the steps that you could run on your GPU in a machine with access to GPU. There are some disclaimers here again, where you're running 3 quantized models, which means that you need enough VRAM to be able to load those models. Or you might want to have different instances because you're running Automatic 11.11, which is hosted as a service, Olama, which exposes a service. So that could be running on a different machine as well. But if you're running it on one machine, you need at least 20 GB of VRAM. I tested this on Paperspace using the P6000 instance, which runs about, I think, 50 cents, or is it $1 an hour? I think. Yeah. Now the default model, the default container that it uses works for LangChain, but uses an older version of Python, which doesn't work for Automatic 11.11. So, but Paperspace also hosts a whole bunch of other variations of the containers, and this is the container that I ended up using for that. And the nice thing is, there's this run on gradient button. So if you do end up, signing up with Gradient, and if you want to run this or follow along these steps, if you click this, all of this information is pre-fed into this. So it will launch a P6000 instance on this container, and it'll load the repo in its entirety.
Quick thing, that image is not cached, so it will take a minute.
Yeah.
It will not be a very fast setup, unfortunately.
Which is why I actually ended up and pre-ran the exercise while James was running his presentation.
You guys work for the same company?
I don't know.
No,
I have never met this guy in my life.
you want chatting though?
No, yeah, no.
Kareem works for the Office of the Governor in Texas.
So, yes. So, but not just that. I mean, yes, it'll take a few seconds to load that because it's not pre-cached. But because we are also downloading three models, each of them is, the 3 language models are about 5 gigs each. That's 15 gigs. The 11, the stable diffusion model is another, few gigs, which is what, it all adds up to about 20 gigs. And downloading that does take a little bit, which is why, as much as I would have loved to sort of walk through the steps, it would have taken far longer. So that's why I just went ahead and, but I will walk you through the steps that I did so you can sort of see.
It's great. I wish I looked at this before. I could have helped. It's cool. I like it.
No worries. Yeah. So again, this is the running instance. This is running on Paperspace at the moment. Again, I asked it, what's your name? And again, in a similar fashion as it was in the screenshot, it responded with, yeah, I'm Llama, from Meta AI and all that stuff. I asked it, okay, portrait of an astronaut riding a motorbike on Mars. It gave me this, hideous looking image. But, again, here are the parameters. Like I said, I asked it a portrait of an astronaut, and it shortened it to just astronaut riding a sports bike on Mars. Here are the parameters. If you like this image, and if you want to generate it on Automatic 11.11, here are the details. And then just to flip things over, the way this project works is, if there is an image already loaded, you can query that image you can ask it questions, and then what it'll do is it'll take this image, it'll pass it to Baklava with the prompt. And what you're seeing here, I asked, okay, describe this image. This is a response from a language model, which was passed this image and this text, and it came up with a 3D rendering of a 3D rendered image of a man in an astronaut suit riding a motorcycle on a desert planet. And it talks about a few more details about it. But so that's the demo. Let's go quickly into Paperspace. So when I click that link, it loaded up that it'll be something like this. Okay, and it cloned the repo. So here's the pre-cloned repo, and it'll drop you on some on screen like this. Now you could go in and you could launch the lab, and you could just run this step at a time, and that's all fine. But see, we already have the code here, so the code is also present in this folder. So what I ended up doing was there on the left hand side there's this terminal tab. I created a bunch of terminals here. On the first terminal, I basically went in and I created a virtual environment for Python. We do ship with the requirements txt with all these versions. This will ensure that if you run this a year from now, a lot of these underlying tools would have changed to different versions. Yeah. Without this requirements txt file, the code is 99% likely not to run. But this is giving, telling Python, I only want these specific versions. And in order to sort of, install that, the command basically is Python install. We do not Python, so pip install. This is an incorrect command. We do pip install at the names of the libraries. But what I'm saying is use the requirement, read them from this requirements txt, and it's basically just feeding everything that I have here to pip, and it's installing all of those things. It goes about installing all of that, and then once it's installed, I just called Streamlit app run. But before I did that, I went in and there's other steps, and you'll notice that so that's the code. Okay, we need to download and run Ollama. We need to download the models. So we do that next. Basically, just copying. So yeah, I just ran those. Basically copied this section, ran it in the terminal. Ollama serve is a long-running process because it's launching an API, which means once you do this, unless you're backgrounding it, you can't. The terminal is blocked, which is fine. I want it that way. Because then I know that Ollama is running successfully. Once Ollama is running, then I run this in a separate terminal, and it's downloading each of these models from Ollama's registry, and each of these, like I said, is a 4.5-5 gigabyte model, and this output is essentially coming from there. After that, I did the last command is Ollama list, which gives me how many models are you seeing that are local, that have been downloaded locally, and this is a confirmation that yes, I downloaded this, I downloaded this, downloaded this. Okay, good. Next one is the command to going down. Okay, this is what happens when you run when you check in a notebook with a long-running task, right? Okay. The next bit is to download the installer for Automatic 11.11 itself. Again, I open up a new terminal, run this. This will install those scripts, and then we install the Dream Shopper model itself, which is again I think about 6 gigs, if I'm not mistaken. And there's yeah, it's called the sampler. Oh. Yeah. So so ran that. Once it's done downloading, make the web UI that we downloaded, the script that we downloaded a step prior, make it executable and run it. Now, if you're running it locally, you don't need the -f. But because we're running in Paperspace, and I wanted to keep the instructions tight, Paperspace will launch the container as you'll drop in a terminal as root. So you need to provide this -f. So web UI will not complain about you running in as root, and it'll just, okay, you know what you're doing, I'll just run this. And this will take another few seconds to a couple minutes, because now what it's doing is it's installing Automatic 11.11 locally on that Paperspace instance or on the computer that you're running. And once it's installed, we're passing it the path to the location where we downloaded the model and the sampler, and it's launching it, with the API mode. Listen is basically launch this application, and API is okay. Also listen, also open up API endpoints for this one. And the next thing is Streamlit Run app, like I mentioned. Now, James mentioned that we could change the port. The default port is 78, or whatever that 7860. But because I didn't change that, I'm using our handy trick of using local tunnel to expose a URL. This step is not needed on Paperspace because Paperspace will give you a publicly accessible IP. So, but again, you can still do that because it's easier to copy, because what Paperspace will give you, it'll be the output of Streamlit, and it'll be the whole HTTP:// IP address. And so you'll have to do a little bit of, stripping out that stuff. But once you have done that, that's when you can just, click that link that local tunnel gives you, and you will have this interface.
Very clean.
Yeah.
It's so cool. So some of the things I'm super impressed with when Kareem showed me his automatic LLM workflows. And for those of you that are kind of new to us, in our labs over the past, 6 months, in the 101 labs, in 102s, we introduced the concept of using Streamlit or ST inside of Python, a lightweight Python web interface, to create front ends to our LangChain code. We've introduced the concepts of, when I say we, but we as a user group have introduced the concepts of using local models like Obama and others in conjunction with externals, but also internal on your own. So if you want to run like your AI code, which is not breaching the external, your organization externally, not breaching the boundaries, maybe you just want to play with running stuff at home. I think this is really interesting how you built on all those concepts of using your local models, creating functions that are called within your Streamlit code. You haven't shown us how we use fine tunes, but you've shared our fine tunes, as well as integrated the your LangChain hub, your front prompts in LangChain hub. And so it's really cool to see a local user member out of Central Texas and Austin put this out here. But also cool to see a lot of the concepts that we've gone over the past 6 months kind of starting to congeal in something that I think is really super duper neat.
Yep. Thanks, Colin. So all of that code again is here. It's in the notebook, but there's also this folder which has the say if you want to take this and just deploy. It's here, and that's what it's got the requirements txt file. Same code that's in the notebook in those blocks is here, and then some instructions down here. But the Streamlit interface is in the app.py, and the LangGraph agent itself is in graph.py, which means that if you want to create application with a different front end, and you don't want, and this is what we were talking about, I think in our one of our calls was when we were having that runnables discussion, is this could all have been in part of a single py file, and it would have been fine. But say I want to expose a LangServe application. I want to expose this application as a LangServe fast API service. Then I would have to strip out, I would sort of tear out the logic from that and then create another application. Or I could just structure my code in such a way that the reusable portions are self-contained, isolated, and now I could create a LangServe application and just include the graph py in it, and it has the agent everything in it. And then the LangServe portion would just expose the right API endpoint, the additional API endpoints that I might need to go with. But just a quick look through this. Again, there's about less than 300 lines of code here, but some interesting bits. It looks at automatic 1111 base URL. If you don't specify one, if it's not in the environment variables, it'll use the local host. Same thing for Olama. If you don't specify it, it'll use localhost. Image LLM is the one that's using Baklava model. Text LLM is the Llama model. And the function calling is the one that is the fine-tuned one that I mentioned. And this is hosted on Olama AI. This is the config object that I mentioned that we're passing. We're basically using this to collect all the parameters that we then pass to the API. Sorry?
Is that your state?
No, that's not my state. No. This is just a just so that it's easy to work with because I need to. All of these are think of this as a structured request object for image generation for packaged into a single class. This is the text to image input again. This is the field description for that. This is the code I shared on the slide, which takes the prompt. The docstring becomes part of the prompt itself. This is what the language model will read, and it'll use it to transform the if it needs to. So here I have an image generation tool that takes a prompt as a string and returns a JSON response with images encoded as base64 string. The prompt is transformed from simple English to a comma-separated mid-journey image generation prompt. And this is where you would tinker with the prompt if you need to make adjustments to it. And this is where I'm passing it I'm filling in the prompt here, and then I'm passing that prompt object, the contents of that as JSON to automatic 1111. That's all this tool is doing. It's basically a runnable that lets you make API calls to automatic 1111. This is again just one of the API calls. Automatic 1111 exposes a ton. There is an API call that gives you a list of all the models, for example, that you have. So you could imagine having another tool that says, okay, that queries, okay, give me all the models that I have, and that gives you the response. And then you can say, you can say that in the prompt, the tool also say that I'm going to pass you a prompt and maybe also the name of the model to use. So it would then pick up that value and then it would just push it through. Again, same thing here. This is the image to text. And then this is where the tool to definition base takes the JSON the tool definition, and it creates a JSON representation of it. This is what gets injected into the prompt itself. So if I go back here, it'll take my tool definition and it'll create this description out of it. Something that meets this format, because this is what the function calling fine-tune was trained on this structure. And then everything after that is basically okay. So here's the prompt being pulled from LangChain Hub. We're passing in the tool description as a partial there. And then we're getting the JSON output from it. The agent state, Ricky, to your question, this is the agent state. Again, it keeps track of all the messages, and it stores the most recent image that was either uploaded or generated. It just hangs on to that. And then this is the everything after that. Again, in the interest of time, I won't go over the code, but this is graph.py. This is your LangGraph agent that is powering the Streamlit application that I just showed. And with that, I think I'll have
Here, I'll stop the share.
Okay, here you
real quick. Let me share Dan's screen. Dan,
Do you want to switch spots?
yeah, that'd be great.
I think that would make sense.
Here, can you hand me that real quick while Dan gets all set up?
Very impressive presentation.
Thank you.
Yeah, thank you so much, Kareem, for I am consistently impressed every day where you demonstrate your knowledge, but also can someone kill it? But also how cool you are about it, right? You're definitely willing to share, which I'm smarter every day. Listening to you, watching what you're doing. Can you hand me that? Cool. Are you in the sessions interface? You are? Oh, cool. Yeah. Oh, you just joined. Okay, cool. And then can you pop this on your thingy? We're going to make you a. Why can't I make you add the spotlight? Hold on. Remove from spotlight. 1 moment. Stop spotlight. I can't make you an assistant for some reason. I see you here. You're a speaker. Oh, can you click that right there? Let's do that. Let's take that. Can you share your screen? Is that available for you? Little share screen thing here. Cool. And then this is going to give you on the projector. I'm going to kill my microphone.
Yeah.
I don't think your video is being shared.
The intention is to apply this.
Not share my screen.
System references. Link the language model to some of this. I noticed that. I was reading something.
Oh, you got to turn on Chrome. A little
family, right? It is.
So while Dan's figuring this stuff out, we're going to let me give him a little introduction here. Spend so much time with LangChain for work because it gives me an opportunity to define agents. It gives me an opportunity to define workflows, scripts, processes, where things that I would do that would take time out of my day. If I think back to my life on a hyperscaler, my life and my team's and organization's lives were improved by finding those 5 minutes that we can get back to each other. 5 minutes I can take out of my day. 5 minutes I could save our support organizations. And so what's interesting with Dan's code is these agents are interacting with themselves in a shared model, But if you think about the agents we write for ourselves, as our scripts, as our automations become more autonomous, maybe there's some patterns that we'll see in Dan's video games that we can use in our lives, in our businesses, in our fun, whether it's managing a social profile or whether it's responding to support requests. I see that Dan is sharing. I'm going to stop talking and let you talk.
Hey, yeah, thanks again for having me. I'm here today to share a project I've been working on, Pixel Valley. Kind of the point of this talk is I'm just going to briefly do it like a high level. I'm not going to go too deep into anything because I've got a lot to cover. And basically what this is about is that I am building an application on top of existing stuff. This is all off-the-shelf kind of software. And I'm kind of pulling things together and building this tool. So who am I? Software architect in Austin for about 15 years, game designer. I'll have some contact info at the end if anybody wants to, follow me on GitHub, hit me up on LinkedIn. I'm a green banner, so that would be great. So what am I building? I'm building Pixel Valley. So I'm just a software architect. I'm not a machine learning. I don't have any machine learning experience. I don't have any data science or anything. I'm just a guy who builds things, right? So what is Pixel Valley? This is, I was laid off in October, and this is an idea I had. I want to learn all the AI technology, and so what better way to do it than build a little game? So what I'm building is user can enter a little prompt, and it will generate an entire AI-driven village for the user. So it's like, it'll do all the buildings, all the characters, all the tools, things the building characters can use. It generates using Stable Diffusion all the game content, and then after it's all created, the player can drop in and interact with the characters. And they're all autonomous. They have their own hopes and dreams and stuff, and they're fun to talk to. So that's a lot. There's a lot of challenges involved there, what I just said. So the first one is procedural generation. How do you generate a village? How do you get game content if you don't know what the user is going to type in there? You don't know what to create with Stable Diffusion or anything. So how do you do that? There's a problem with the autonomous generative agents. Like, how do you get these agents that work and talk to each other and make them behave in a way that's believable and fun? Which brings me to the next one, which is game design. I'm not going to get into that too much today, but there's some game design problems involved there. It's an AI village. Like, there's not really any goals. Where's the fun, right? So there's a lot of challenges there. And then the DevOps and ML ops, which previous speakers have kind of touched on a little bit. I haven't figured that out yet, so I'm not gonna talk about that. I'm still haven't figured out like where to put all this stuff in the cloud. So that's a lot of challenges. I'm just one guy. Is it possible? And it totally is. So I've been kind of hacking on this. This is kind of what I've come up with. So it's this is from the prompt Pirate Village. It's generated all these different. First, it generated decided the types of buildings that would go in there. Created all the artwork in Stable Diffusion, and then this is all stitched together in Python. You can see we got the little character heads that shows like who's where they're hanging out, what they're doing. So this was just from the prompt Pirate Village. This is all AI generated. This is an ancient Greek city. So you can see it's got more of a kind of a ancient Greece theme. We've got like some little Greek people kind of running around and stuff. This is the High Elves. This is an experiment I was doing because when it generates the characters, it gives them all like a name, an age, gender, and I wanted to see if I said, hey, these are elves, and yeah, it worked because these are all hundreds of years old is what it decided. They're all extremely old. And then this is like inside of a building. So this is what it came up with. These are 3 characters that are in the blacksmith. And you can't really tell by looking at this, but one of these characters has decided she's going to be the world's greatest swordsman. And to do that, she needs to get to that goal, she made a short-term goal of create the world's greatest sword. And she has talked to these other 2 characters, and they are all working together to forge a sword. They're in the blacksmith shop talking to each other, using tools and stuff. This is I stood up a really quick chat interface just to make sure everything was working. I put this together in a few hours with Streamlit and LangChain, just to see if it was working, and it totally is. So I'm talking to a pirate. Have you talked to anyone lately? And the summarize with response with some conversations that she had previous. And these are all real answers. She did actually have those conversations. So this worked really cool, and I was really impressed with it. And again, LangChain and Streamlit makes this super easy. Like, just if you need to hack something together really quick, it's very easy with Streamlit and LangChain. So let's talk about the first part, is the procedural generation. So user types in a prompt. How are you going to get that prompt and generate all this stuff? So here's some of the tools that I'm using. Using LangChain, using a large language model. I'm using GPT 3.5 Turbo. Just fast and cheap and super easy to use. I'm using the AI function calling that we talked about previously, which is supported by GPT 3.5 Turbo, so I didn't have to do any fine tuning or anything. Python, Streamlit, yeah. So LangChain, I'm super well touched on it. We all know a little bit about it. Super easy to use, flexible. You can swap out components and stuff. So this is an example of where I might be using this. So users type in a pirate village, and I say, system message, expand the description of that scenario. I want like a big description. I can't just say it's a pirate village. It's got to be long and fun, right? And so, this is kind of what it comes out with, a big, long thing. Crystal clear, turquoise waters, that's much better. So we can get a lot more out of this. I put this slide in here, recommended reading. These are the two books that I use to learn LangChain. I very much definitely recommend the Greg Lim book was really good. The ML Bear book was okay. I think that he's a machine learning guy, and you can tell, I think he used it to create this book. It's a little, it reads like a machine learning. It was written by ChatGPT. Greg Lim is really good. I recommend all of his stuff. I read all of his books. But the ML Bear it's useful, but it's also like a little ChatGPT-ish. And an AI function calling. This is a tool that I use. This is it's just so basically this is letting the LLM call into your own code, and then specifying like an interface for that. So it doesn't actually call into your code. It just sends back the JSON of what the call should look like and all the parameters and stuff that it should pass in. And I'll show you an example. So why should we use this? So here's an example of like if you're just using like ChatGPT or just like a text LLM. So this is an example somebody showed me of how they're doing it. You're a thief. You must choose your next action. You can be only one of the following actions. He's got some enumerated values. Only output JSON and nothing else. So he's described what he wants his output to be. And then in order to take a text output and do something with it, it's got to be in some sort of consumable format. And so this is what he got. And that is consumable. It's thinking, it's got the action. So it's what he described. The problem with that is that that's a very simple response. And if you want to do something more complicated, like I don't know how, so like you do something like AI function calling. So I've got a scenario, and I need a whole list of buildings. I need an array of them. I need names for them. I need a description. I want to know if it's a building. I'm going to go back in and do rooms. So I can use recursion actually in AI function calling, stuff like that. And I couldn't even describe how to do this in plain text. I don't know how you would describe this and get a usable answer. So this just gives you like a data contract that you can pass to the large language model, and you get something usable back. And yeah, it gets some great results with this. So like here's an example using AI function calling. You can see it's got like the name, it's got the description, and then I went back into Stable Diffusion and kicked out some assets for that. And then the recursion, you got to make sure you add a break condition though if you're going to do that. I ran into like an example where it generated a castle, and I went and got a cup of coffee and came back in and it's still running. I'm like, what is it thinking so hard about? It had created like a fractal labyrinth underneath the castle. I didn't have a break condition. And it was just like, all these rooms, and it was just going, and it was just going and going and going. Okay, you got to stop. This cost me a fortune, right? So the next part of procedural generation, once you've got all that text, I've got my scenario, I've got all the buildings I want, all the rooms I want to build, all the characters and stuff. Kick it over to Stable Diffusion, which is kind of an art form of itself. So you got to find the best model. You got to there's things called LoRa's, Learn on Reconstruction and Attention. It's basically like a Photoshop filter for Stable Diffusion, where you can kind of fine tune your results a little bit. Prompting, negative prompting, those are super important. And then I put Yikes. Stable Diffusion is a very active community. You've been warned. So first, finding the model. I think you mentioned Dreamshaper. This is like a super easy to use. You get great results with Dreamshaper. This is one that I'm using. It's very good at doing characters. Models are very specialized though. Dreamshaper is great at doing characters. It sucks at everything else. You can get awesome characters very easily, but like you'll never get a building out of it. Some of them are easier to use than others. And then you can use LoRa's to refine results. So like they have different LoRa's you can use to like kind of like this one right here. This is from a LoRa. So I said, I need a theater, and then there's a LoRa on Civit AI that it does like this isometric 30-degree thing, kind of, and shapes it, and then that's how I'm able to get like these consistent results with Stable Diffusion. It's felt like a big win getting consistent, reusable results out of Stable Diffusion that I can put in the game. It's very difficult. It's very hard. A lot of people are trying to do that right now. Prompting and negative prompting. So basically what I'm doing is, I've got the scenario, I've got the location name. So I've got this whole prompt set up beforehand, and then just attach the user input at the end over there. I've got the prompting, but then also the negative prompting is super important. What you don't want your results to look like. So you'll see a lot of things. People put like bad quality, low quality, watermarks, signatures. You can put parentheses around things to emphasize. That's super important. Like I want this to be, all my buildings to be isometric, that 30 degrees. So I've got 3 sets of parentheses around that. And then you can see this is the LoRa right there where it's got the 4 at the end. I'm really leaning on that really hard to get those results. So at that point, we've got the whole city generated. Got all the characters in there. But now how do we interact with them? And that's where we come to the autonomous generative agents. This is based on a famous paper from last year. It leans on a technique called retrieval augmented generation RAG, which is very popular right now. Re-rank, which is a technique for getting better results out of your RAG pipeline. And then at the end, I kind of want to touch on hallucinations a little bit, where it applies to generative agents in video games in particular. Everything that we're building is, standing on the shoulders of giants. So these are some of the papers that I've been, reading, that I've been building stuff on. The big one was generative agents, which is basically where I got this whole idea from. You can see this is their this is their village right here. It's kind of pre-built, kind of like a old school RPG game. And then these are some other cool papers that people have written about generative agents and things like that. And so what are we trying to achieve with these agents and these NPCs? So basically we want them to have like memory. We want them to remember what we talk to them about, what they do. They want to have long-term goals, short-term goals. I want them to use those goals to, in their memories, to do like a daily plan. When they wake up in the morning, what are they going to do? Decide what to do based on all that. They can use tools, they can talk to each other, they can talk to the player, and they can all work together to do stuff and accomplish all these goals and stuff. And this is basically like the pipeline that we're going to use. Is so the agents like see something, it gets put in this memory stream, and then when we want to do something, we pull memories out based on what we're trying to do. So if ask them like, where do you want to go? What do you try? And it'll say like, well, I'm trying to make a sword. It'll pull out all their memories related to building a sword, and then decide where to go from there. That's kind of like a super high level. And that's all done using retrieval augmented generation. So basically, the whole memory stream is all stored in. I'm using MongoDB. There's a bunch of them. Do I have a slide about that? Yeah, here we go. So yeah, it's basically. Let me see. So it's a technique. Instead of fine-tuning your model, it's where you pass all your data into the request as context, and large language model uses that to make a decision and get a response back to you. And so how we're going to do that is first you need like an embedding. So what that is that it's taking a piece of text and it's assigning a huge string of numbers to it. And then you store that in something called a vector storage. It could be like a Weaviate or Pinecone. I'm using MongoDB. They have a vector embedding storage. And then basically from there, when you want to get a query, it'll take your query, it'll convert that with the embedding, get another long string of numbers. It does a piece of math to find pieces of text that are adjacent to each other. And then that's what it uses to return that, and then you pass that as context to your large language model request. That's like a super high level of how that works. It's actually pretty easy to do with LangChain. So doing a re-rank. So part of the RAG pipeline is making sure that it's passing the best data to the context, if that makes sense. And so it's a difference between a memory versus data. So like with these agents, it's not just a piece of data that's being sent in, it's a memory, and those have specific, it's different, like memories can be important, they can be recent. And so we have to do some kind of calculation of what we want to, when the agent's trying to make a decision, what do we want to use to make the decision? And so this is like a real basic algorithm of it's adding up the recency, the importance, and the relevance, and then using that to use a score to re-rank and bubble up the most important things every time. This is what we're trying to accomplish. So it says, what are you looking forward to most right now? It's going through the memory stream, finding the most, doing that thing, and then it's down here, it's looking forward to a Valentine's Day party. So this is I thought I'd talk about this hallucination. Everybody says it's super bad. Sometimes it's actually not that bad. So we're doing video games here. So in LLMs, it can show you the temperature, and it's like a porch too hot, porch too cold kind of situation. And is it always bad? I don't think it is. So the porch is too cold. This is if you run your LLM queries like all the way as cold as possible. The upside of that is that you get concise answers only from the context. You don't get very little hallucination from that. The cons for that, well, I mean, if you're doing something in business, that's probably good. But if the cons are, it gives like really lifeless answers. You get this as an AI language model, I can't answer that or whatever. It gives up, and then it repeats itself like a lot. It's kind of a joke there. Also, porch too hot. This is so that was boring. So I started running my queries like all the way to the other end of the temperature. I get some great answers, but the problems there are, one, it breaks AI function calling. So it's got to be, using that like depending on it to be like valid JSON when it comes back. If you let the LLM go too wild, it won't return valid JSON sometimes anymore. So you have to kind of dial it back. And then also you get invalid game state. So like you talk to a pirate and say like, what are you doing today? And he'll say, I'm sailing to the island and I'm with Captain Blackbeard and we're gonna fight the dragon and get the treasure. And that's going to be our day. And it's like, wow, that sounds like awesome. Except the only problem is that none of those things exist in this game. Like that's great, but yeah, you just broke the game. Like you can't do any of that. So you got to dial it back. I run into, I found like, it's a kind of an art of trial and error, So yeah, so we're just, and then the port's just right. We're making a video game. This isn't rocket surgery, So if they, you want to run it a little hot. So if they say in character, like, if you're talking to a Viking, you want them to talk like a Viking, like not like a large language model. And also, it's fun to let him hallucinate a little bit because, like, pirates lie. Like, if he says he's the best pirate in the world, it's like, okay, bud, sure you are. You know, it's whatever. Like, just let him lie. So yeah, there's some game design challenges. You can see these two guys are playing this game very hard. This is definitely not the game. They're not playing Pixel Valley. Like, this is not an intense game. It's probably not for those guys. You know, where's the fun in this game? You know, who's the game for? It's who's going to play a game about chatting with pirates and Vikings and stuff. I don't know. I think it's cool. I mean, try to get some streamers to play it. I think it'd be fun to do it like a stream of this. Those are all things I'm working on. And then the far future goals. So I'm building this like this is a project that I'm building, like a video game. Eventually, like doing NPCs as a service, maybe productize the generative agent part of it, and do like a like NPCs as a service. Like if some other game developer wants to have some agents running around for flavor, they could just do like an API call and drop it in. That's something that I'm thinking about. Trying to get funded. It's hard. I'm just, you know, this is all bootstrap right now. Text to voice. I have some interesting. Well, there's interesting problems there because you know, a lot of the text to voice stuff right now is you need to have like a voice actor. You need to fine tune your model every time. But for something like this, like we don't. If someone says, "Okay, it's a pirate," I don't have a pirate voice actor, so like, how do you do that? I don't know. It's kind of an interesting problem that nobody's really working on. I don't think. I'd like to. I'd like to see somebody kind of figure that out. And then finite state machines. This is useful? Question mark. I don't know. This is something cool that I've found that LLM could do, and I couldn't figure out what to do with it. So I was like, I just kind of tore it out. Yeah, and that's pretty much my talk. That was kind of super high level. I don't know if anybody has any questions. I got my contact info there. Yes. That's a great question. It's not actually stood up anywhere yet. I'm sorry. I'm working on it. Soonish. I could probably like next week. I got the GraphQL stood up like this week, so the API stood up. I need to stand up the front end somewhere. I'm working on it. I'm working on it. Yes.
How do I find out?
How do you find out about this project? It's on my right now. It's just on my GitHub. DMaining23, Pixel Valley.
When it's live, can you post it to the Discord?
Yeah, absolutely. Yeah, yeah. I was gonna go in there anyway too. Like, you know, I'm always like, if you go on my GitHub, I have hundreds of repos on there. Like, I'm always just hacking on stuff, and I've got probably like a dozen LangChain projects on there that I could drop in the Discord. Doing different things, like a lot of Stable Diffusion projects, LangChain Stable Diffusion, different chatbots, cover letter creators, resume creators, things like that. Yeah, I could drop all that stuff in there too. Yes, sir.
You mentioned the word finite state machines.
Yes.
But I didn't hear in the context. Did you say LLM or?
Yeah. So I put together like this big AI function call. So basically, like, there's lots of items in this game, like a coffee pot or something, and I want the pirates or the characters to be able to use them. So a finite state machine, what it is basically like if you're not familiar with it, it's like it's got states, it's got messages, and then it responds to messages and changes state depending on what state it is and what message it gets. And I wrote an AI function call where the LLM can actually create those convincingly. So like you say, convincingly. Yeah, so you can ask GPT-3.5 like, I need a coffee pot, and it'll say like it's got like off, on, full of water, brewing.
In what language?
It's just like plain text. I mean, so it's basically like say it's an AI function call, so it's coming back as like a JSON, like basically like a JSON. And then
the various states are shown in the JSON.
Yes, yeah, exactly.
But not the computer program that would run through it.
Well, that's the problem too. Is that like the LLM? I would say like, okay, you've got this coffee pot. You know all the states, all the messages that you can do with it, all the transitions that go. Brew a cup of coffee, and it could kind of struggle. So it's there though. I think the code is still up there. I could share that. How to generate a finite state machine with GPT 3.5. It was cool. I couldn't get it to work. I couldn't get the LLM to properly interact with it. And sometimes it gave goofy results.
What language is your game written in? What's your programming language?
Oh, interesting. Great question. It's mostly Python. Node.js on the front end. Let's see, GraphQL, lots of GraphQL stuff. Yeah, Python. Yeah, mostly Python. Yeah.
Well, any other questions?
Is the goal, so it's, at this point, it's like almost like watching, like an aquarium, right?
Yes, yeah.
At some point, we allow people to come in and find their own characters, and they can just kind of like check in on them, like see how the autonomous agent is doing.
Exactly. Yeah. Yeah. Like I could, and sometimes like even though it's like kind of, I think I've got it running somewhere.
Can we? I know it's early; it hasn't really.
Yeah.
Can we see it?
Yeah. Yeah.
It's super cool, by the way.
Oh,
This
thank
is
you.
like
Thank
such
you.
a rad way of putting this all together, man. It's awesome.
I can almost imagine someone over Black Hat doing a version of this where they're trying to hack each other.
Yeah.
Yeah.
Exactly. Make like a capture the flag almost. Just a totally different like genre of game, but same framework, same essence.
Yeah.
So let me see if it's running somewhere.
The demo gods are harsh, so if this pulls up, no one's gonna.
Yeah, do a demo, lose a sale, right?
Yeah.
Let me see. I'm gonna need. So here's kind of a cool one. So this is from the prompt.
Just different worlds already.
Yes, I have several of them. Yes.
Scenarios.
It should be running. It is not running.
This concept of character building is so neat. My brother, who's the main attorney here behind the firm, he held a costume party in New Orleans that was like based in 1920s. And it took him a while to get the prompting right, like took all his favorite authors and all this, but now he's got this prompt where he can tell it like, here's Pedram and a couple of things, like make him into a 1920s character. And like it's just like the prose that comes out of it, the description of what you wear and like the linguistics that you would use at the time. It's just so awesome. Like, Dan just took this to video game world.
Yeah. Yeah. So here's like a Viking village. Let me see.
How does time work? Is it turn-based? Like, does each character get a chance to make a move?
Yeah. So basically, it's just time just runs it. There's a microservice, just a Python microservice on the back end that just kicks off 15-minute increments, and whenever it flips over, it just updates the entire game state. So it's not like real time. It does take quite a while to because it's got to go back and forth to the LLM, all that stuff.
But then these things will move if you stay here and watch it.
Yes.
And how do you how do you look at like their conversations they're having or like introspect what's going on?
Well, that I'm still working on. So like here's Ingrid the healer. You can see some information about her. You can get like a description. This is like what it came up with, which was passed to Stable Diffusion to create all the character artwork. Eventually, users will be able to like come in here and tweak this a little bit if they don't like something about the character. You can see all the goals that she's come up with. She wants to learn about medicinal plants. She wants to teach an apprentice, create Woodruff survival kit, all this stuff, right? And then this is what she's decided to do with her day to accomplish all those goals, right? She wants to explore the Arctic tundra, teach healing methods, doing all this stuff.
You ever consider piping in like business data and having a project manager fill this role, or have this fill the role of a project manager?
Yes, I've thought about like having them be like microservices that you program with plain text. Like, so spin up an agent and say, you sit here, you watch this endpoint. When a piece of data comes in, you transform it and kick it out this other endpoint. So you don't have to program them, right? And then if something goes wrong, instead of blowing up your PagerDuty, they come chat with you and they say, like, hey, something's going wrong. I need to go talk to this other agent. Or they can talk to the other guys in the pipeline and figure out what's going on. Yeah, something like that would be cool. Yes.
Are your agents only characters currently? In other words, do you have any other kinds of agents, like a master agent?
Or could you model time itself as an agent so that things would move along depending on how that agent thought about how things should move in the game? Maybe a game master agent could control and nudge characters to do certain things if the plot's getting a little slow or something.
Cause
interesting.
floods, and
Yeah.
drop hurricanes, this kind of thing.
Yeah, you can model the weather itself as an agent.
Yeah. Okay. Yeah, that's interesting. Yeah. I'm gonna write that down.
Or the environment.
Yeah.
Animals.
Chaos monkey that goes and just.
Yeah.
Or model the plot of the stories of agents, so it can follow its own, idea itself.
Yeah, like it has a storyline behind it that is trying to guide you
You may not
towards.
know it at that time, but it can think about it and keep working on it as it moves. And you could give it access to all the memories of all the characters, so it's a mission.
Yeah. Okay. Yeah, I totally get it. Yeah, that'd be awesome. Oh, okay. I see what's going on. I mean, that's interesting though, because like, yeah, this is kind of, you know, they go run around and do stuff, but it's, there's really no goal to the game, you know? So maybe that'd be a way to introduce some sort of goal or something. But I showed this one because like, even though it's like, there's no goal or anything, there is kind of a mystery is that all of these agents have decided this is Atlantis and they're all in the Temple of Poseidon reading books. I have no idea why. Like, so maybe I could go there and talk to them like, why are you guys all in here reading books together? Like, what is going on?
You're a game designer, right?
Yes.
This is really interesting. This is like, you could do like, this is like Monte Carlo simulation for each scenario.
Yeah.
I think that's fascinating. Like, you know, veteran brother Nima, you know, this would be really interesting to like load up characters with like affidavits and you like simulate how a court case is going to go based on like the jurors' attitudes, and like this is a really just fascinating way to choreograph like strategic actions in like a complex environment, and just to see all the different ways that it can play out.
Yeah,
that's fascinating.
Yeah, there's a lot of possibility, and there's some people working on this, but this is all brand new. Like I said, the papers were all from last year, so like this is all. Nobody's working on this yet. Nobody's really thinking about it. I mean, people are thinking about it, but like, there's not a lot of work being done with agents and games, like just possibilities. And there's a lot. There is the work that I'm seeing being done is all towards traditional games. Like, how do we do a big, you know, the kids that were sitting there mashing on the controllers? How do we make games with this for those guys? And like, I don't really know if it's really a good fit. You know, this is more like a storytelling thing, not like an action game. Like, you know, LLMs are like a tool in your tool belt. And when you're making a game, if it's a fast-paced, goal-oriented game, maybe it's not a tool you can control right now. Or something like this, like a Pride and Prejudice LARP. They do this in Austin. Something I found out about, and so I thought maybe this would be something fun for those kind of people. Like you can come here and I think I typed in a Jane Austen village, and this is what it came up with. It's all the Pride and Prejudice characters doing stuff, talking to each other. If I was a big Pride and Prejudice fan, I could come in here and, you know, set them up against each other and do, you know, mess with them. Kind of fun.
Wow. It would be fun to run like classic fairy tales through this, and you can like check in after the happily ever after.
Yeah.
Like, whatever happened with Cinderella and the Prince?
50% chance to force after 7 years.
Hundreds of other desktop work.
Yeah.
Feed in a rule book to it from those games, and it could basically simulate.
Yeah. Cool. Are you taking notes?
Yes.
I think I could run for 10,000 years and see where their societies develop.
Yeah. Well, I mean, I think at that point, like my MongoDB bill would. Like...
Awesome. Well, at this point, I want to go ahead and, of course, we can all continue chatting afterwards. Perfectly fine. I do want to be respectful of everyone's needs to get to bed and whatnot. And remind people this is an ongoing thing. Our point here is to connect people, to inspire each other, to improve our skills in what we're doing, and to enjoy this really cool project. Dan, thank you so much. Hopefully we can hang out more after.
Yeah.
I want to make a quick request. If you are sitting